Why does your phone need a whole sky full of GPS satellites just to tell you where you are? Because GPS isn't looking at you. It's doing a time geometry trick. And the more satellites you have, the more that trick stays accurate when the real world starts cheating. Start with the basic idea. Each satellite continuously broadcasts two things: who it is and exactly what time it sent the signal. Your phone receives that signal a tiny fraction of a second later. Multiply that travel time by the speed of light, and you get a distance. In theory, one satellite tells you you are somewhere on a sphere centered on that satellite. Two satellites gives you the intersection of two spheres, a circle. Three satellites narrows it to two possible points. Usually one point is ridiculous, like floating far above Earth, so you can pick the one on or near the surface. That's the clean, textbook story. Reality is nastier, because the one measurement GPS cares about, time, is the one thing your phone is worst at. Satellites carry atomic clocks. Your phone does not. If your phone's clock is off by just 1 microsecond, the computed distance is off by about 300 meters. One tiny blink, and your sphere balloons or shrinks by the length of 3 football fields. So your phone doesn't just solve for position. It solves for position plus a clock correction. That's 4 unknowns: latitude, longitude, altitude, and clock bias. And that's why you need at least 4 satellites for a true 3D fix. Now here's the part people miss: 4 is only the minimum, like saying you only need 3 legs to make a stool stand. Sure, but it'll wobble, and any push will move it. GPS has to work while satellites move, while Earth rotates, while signals get delayed, and while half the sky can disappear behind buildings. That's why so many satellites exist. Reason 1: coverage. A satellite only helps when it's above your horizon, and each one only covers part of the planet at any moment. A full constellation in medium Earth orbit keeps several satellites visible from almost anywhere, almost all the time, so you're not waiting for the next one to rise. Reason 2: geometry. This is the real trick. Even with 4 satellites, the shape of the satellites in your sky can make your solution either tight or trash. If the satellites are bunched together, your distant spheres intersect in a long, smeared region. Your phone can slide along that region and still fit the timing data. Engineers call this dilution of precision. Bad geometry amplifies small timing errors into big position errors. A quick mental picture: you're trying to locate a sound by how loud it is. If all your microphones are on one side of the room, you can't pin the source down well. Spread microphones around you, and the location snaps into place. Satellites work the same way. Wide angles give strong triangulation. Narrow angles give guesswork. Reason 3: error rejection. GPS signals don't always take a straight path. In cities, they bounce off glass and metal, multipath, so your phone measures a longer path than reality. In the upper atmosphere, charged particles slow the signal slightly. In the lower atmosphere, water vapor adds delay. Your receiver uses extra satellites to cross-check measurements, detect outliers, and throw away the liar signal. More satellites means the receiver can be picky instead of desperate. Reason 4: tough environments. In a street canyon, you may only see a thin strip of sky. In a forest, leaves weaken signals. In a car, your roofline blocks low-elevation satellites. If you only had a few satellites total, you'd constantly drop below the 4-satellite minimum. With many, the odds are better that 4 strong, well-separated signals survive. And today there's another boost. Your phone often listens to multiple constellations: GPS, Galileo, GLONASS, Beidou, then chooses the best mix for geometry and signal quality. That's like going from 4 microphones to 20. So the headline is simple: GPS needs many satellites because the world is full of blockers, bouncers, and time delays. Every extra satellite adds another time-distance measurement, and the more spread out those measurements are, the tighter your answer becomes. Next time your blue dot jitters, remember, it's not your phone being dumb. It's geometry wrestling reality. What breaks GPS more in your experience: tall city buildings, heavy trees, or going indoors?